Hey class, this is L2 practice, problem number 2. So the question is asking us to find the equation of the tangent line to the graph f of x, given that f of x is 5 square root of x minus 4, and we are looking at the point where x is equal to 1. Now, I like to go ahead when I see these types of questions, I want to see a point on the graph, right? What point am I looking at? So given that x is 1, f of 1, which is the y value, is 5 times square root of 1 minus 4. Square root of 1 is 1 times 5 is 5 minus 4 is 1. So the point that we're looking at is the point 1, 1. Okay, so keep that in mind. However the graph looked like, we are looking at the point 1, 1. So let's go ahead and do this algebraically or using calculus first. And then we're going to go ahead and exhibit that on a graph so we can kind of really understand what we are doing here in terms of a visual of the math, okay? So the slope of the tangent line is the derivative of the function. So slope at any given point is defined as, and the limit definition of the derivative is limit as h goes to 0 of what? F of x plus h minus f of x all divided by h. Okay, and you should have that visual in your head from lesson 1, the definition. Okay, so then again, the derivative is going to be limit as h go to 0. The denominator is h. The numerator is, I'm going to go ahead and put the f of x plus h in parentheses. I will have 5 square root of x plus h minus 4. That is f of x plus h. That's this right here. Okay. Minus f of x. And f of x is the function itself. So minus 5 square root of x minus 4. Okay, now distribute, and when I distribute, I will see then that limit as h go to 0 of, okay, minus 4, this is going to be plus 4, right, and this is going to be minus. So then I will have 5 square root of x plus h minus square root of 5x divided by h. Okay. Now, I can't just go ahead and say, oh, h is going to go to 0. So this is 0, this is 0. Well, can't do that because we can't just plug in 0. It's not a direct substitution right here. We cannot do that, right? Because we can't divide by 0. However, if we change the way this expression looks, we can go ahead and do a direct substitution. Now, how do I change the way this expression looks? Gonna have to multiply by 1 because it's a fraction, right? Which one are we multiplying by? We are multiplying by the conjugate. So what we're going to do is we are going to rationalize the numerator. Okay, so that would be here a minus b right here in that form. So I'm going to go ahead and multiply by a plus b, right? So that will be 5 square root of x plus h plus 5 square root of x. The same thing on the denominator, so that we are only multiplying by 1 and it's not going to change our expression. is going to be 5 square root of x. There you go. Okay, so when I do that, I would get limit as h goes to 0. The denominator will have h, 5 square root of x plus h, plus 5 square root of x. And on the numerator, I would have this first term right here, square, right? This is a minus b multiplied by a plus b. So I will have a squared minus b squared, the difference of two squares. And the difference of two squares at a squared, which is 5 squared, is 25. Square root of x plus h squared is going to be square x plus h. So I will have 25 times x plus h. That is the a squared minus 25 times x. Okay, now when we distribute and clean that up, we will see that the 25x minus 25x is going to be gone. So I will have on the numerator, I will just have here's 25x plus 25h, and then 25x minus 25x, that's gone. All I have is 25h divided by h. What I will have left is 25 on the numerator. Limit as h goes to 0. 25 on the numerator. On the denominator, I have 5 times square root of x plus h plus 5 times square root of x. I can reduce further and say, hey, look at that. 25 divided by 5 is 5. And all of these are 1. Divide everything by 5, right? So what I have left is 5 on the numerator. And when h is approaching 0, x plus h is going to be very close to just x. So I will have square root of x plus square root of x, which is 2 square root of x. So that is the derivative evaluated at x. Now, what does the derivative represent? The derivative is the slope of the tangent line, okay, at any given moment x. Well, what moment x are we looking at? Let's just go ahead and review what we have so far. We're looking at the function f of x is equal to 5 square root of x minus 4. And we are looking at the point x equal to 1, which we did some math and say really we're looking at the point 1, 1, because when x is 1, y is 1. From there, we calculated the derivative. The derivative is 5 divided by 2 square root of x. So when x is 1, then the derivative evaluated at 1 is 5 over 2 square root of 1, which is just 5 over 2. This right here represents the slope of the tangent line at the point 1, 1. Okay, so we have the slope being 5 over 2. The point is 1, 1. We can say now y equals mx plus b. M is going to be 5 over 2. X is 1 equals b is 1. I mean, not b is 1, y is 1, and b is the unknown, right? So minus 5 over 2 to the other side, we will have b is negative 3 over 2. So the equation then of the tangent line at x equal to 1 is y equals 5 over 2x minus 3 over 2. That's the equation of the tangent line. Now, we can visualize this on a graph. Okay, so let's visualize this on a graph. The function is f of x is 5 square root of x minus 4. Okay, so when we are looking at this graph right here, by transformation, we know that we are going to shift the graph down 4. Okay, so this would be down 4, and this would be a vertical stretch of 5. Okay, down 4. 1, 2, 3, 4. Down 4. Normal is over 1, up 1, but we have a vertical stretch of 5, so we will go over 1, up 5. And there is our point 1, 1 on the graph. Okay, there is our point 1, 1 on the graph. And then if you really want to, we would say normal square root of x is over 1, 2, 3, 4, over 4 up 2. But we are having a vertical stretch of 5, so 2 times 5 is 10. So we're going to go over 4 up 10, so that's 5, 6, 7, 8, 9, 10. Okay, and the square root graph would be like this. And we know the shape, but if you really want to, you can say we're going to have to go over 9. Okay, over 9, normal is up 3, so then over 9 up 15 from the vertex. And the equation that we have found is the tangent line is y equals 5 over 2x minus 3 over 2. Well, where is that line? 3 over 2, here is that, right? Here's the point 1, 1. Okay, so the tangent line is going to cross that line. It has a y-intercept of negative 3 over 2, and it has the slope of up 5 over 2. That tangent line right there is this equation here. That's the tangent line. Okay, and this right here is the function f of x, and the slope of that line, 5 over 2, is the derivative evaluated at 1. Okay, there we go. That's graphically how things work in terms of the derivative of a function and its tangent line.